This is Agriculture Today, and I'm Shelby Varner with the K-State Radio Network. In a two-part segment, K-State Extension wheat pathologist and disease specialist Kelsey Andersen Onofre and Erick DeWolf discuss wheat streak mosaic, wheat soilborne mosaic virus, wheat spindle streak mosaic virus, barley yellow dwarf, and stripe rust. They talk about what growers should be scouting for and what they should do to prepare. K-State dairy specialist Mike Brouk ends today's show by introducing us to the recipients of the 2024 Kansas Distinguished Dairy, Steve and Cindi Ohlde, and their family with Ohlde Family Farms that has 6 sites. That and more is coming up ahead on Agriculture Today. You're tuned in to Agriculture Today, and we start our Tuesday show talking about wheat viruses as things are greening up. And then to talk about it, we're joined by 2 K-State Extension wheat pathologist and disease specialist, Kelsey Andersen Onofre and Erick DeWolf. Kelsey, Erick, thank you both so much for taking the time to join us today.
Thanks for having us.
Yeah, you're welcome.
Kelsey, our first virus to talk about today, wheat streak mosaic. And what is wheat streak mosaic?
So when we're talking about wheat streak mosaic, we're actually talking about a few different viruses, right? So there's the wheat streak mosaic virus. There's another one called triticum mosaic virus. There's one called high plains disease, or sometimes wheat mosaic virus. And they kind of are this family of viruses that are vectored by a tiny mite that we call the wheat curl mite, right? And they all cause really similar symptoms. So they cause some yellow and green streaking in our wheat plants. And this is really a disease that can be a big problem. We see it a good amount in western Kansas, but we've also seen it in the central part of the state here over the last few years. And what really makes this one hard to control is that these curl mites, they survive in volunteer wheat. So if you had some wheat in a neighboring field that survived after harvest, or maybe it was hidden in some, double crop field nearby, that's where those curl mites, they survive. And they can then blow into your field in either the fall or the early spring. And that's typically when we start to see some damage, right? So it's one that it can be really problematic, and it's important that we test for it and identify it early.
Are producers able to go out in their field and recognize and identify it?
Yeah, so, the streaking symptoms, they're pretty characteristic. I guess a key point is that, usually we don't see that streaking symptom until the weather starts to warm, right? So we can have some infection cooking there over the winter, but the symptoms don't necessarily show up until it starts to warm. And, when we start to see them early, that's when we're a little bit nervous. If you're unsure, right, so there's a couple things that, can key you into this being wheat streak mosaic, right? One might be that you get a kind of a fan appearance, so it kind of is worse on the edge of the field and gets, kind of progressively better as you move towards the field, kind of the gradient of where those mites were. That's one other way you can diagnose in a field. The best way, though, to know if you have wheat streak or not is to talk to your local K-State Extension agent and pull a sample and send that into our diagnostic lab here in the Department of Plant Pathology. So they can run a panel of tests and let you know for sure if that's what you have or if you have something else.
If producers do see they have wheat streak mosaic, what should they do?
Yeah, so that's where it gets a little bit tricky. So that's where we really need to evaluate, and maybe I'll pass this over to my colleague Erick DeWolf here, but that's when we really need to evaluate the potential of the crop, right? So there are a few things that will typically affect how bad our yield loss will be. One is how early that infection happened. So if you see the symptoms in the fall or the early spring, you're probably going to see more yield loss in that part of the field than if you see symptoms later in the spring. The other thing, you could, if you're looking at a really large area affected very early, you might have a discussion about, termination and planting a different summer crop, right? That's kind of the worst case scenario, though, of course. So that's really something to to think through. The best thing to do to manage is to manage volunteer after harvest, right? That's really our big step for combating the disease. The other thing is we do have a few different resistance genes available. So you can just double check your variety too in your Kansas Wheat Variety Guide. And that can also help determine your yield potential, right? If you have a variety that's a little more resistant, you might be able to get away with not taking any action. But it's not a good day if you see wheat streak mosaic in your field, right? So that's why we really put a lot of messaging out right at that post-harvest period to control volunteer wheat.
Yeah, so I would just add, I think there's two different phases to wheat disease management, or wheat streak mosaic in this case. So one would be, like Kelsey just mentioned, that as the previous crop would have been maturing and harvested, we're primarily concerned about controlling volunteer wheat during last summer and last fall. That's the reservoir for both the virus and for the wheat curl mites that ultimately spread these viruses to the new crop as it's beginning to emerge and get going in the fall, and then continues to spread into the spring. So what we're seeing now is the result of what happened last summer and last fall. And now the question becomes, so if I'm seeing the virus now in my field, is there anything that I could still do to try and prevent further spread? And that's a very different question, because unlike a lot of fungal diseases, there's really nothing we can spray or nothing that we could do proactively to in a response or emergency kind of way to control or eliminate the virus at this point. So everything that all of the disease management for these viruses is primarily going to happen in the previous year when we're either choosing varieties or the decisions we made to control that volunteer wheat.
Kelsey, what conditions with that volunteer wheat made it favorable for producers to possibly see this more in their fields this year?
Yeah, so a few things happened in some parts of the state last year that could have led to an increase in volunteer. In parts of the state, we had some unfortunate rainfall right around harvest, so that kept wheat in the field a little longer than we might have wanted to see it. So we could have had some shattering or just some volunteer from that wheat being left in the field for a little bit too long. We also had hail. So there was swaths of hail that came in prior to harvest, and the hail knocked that wheat right out of the plant, and that will cause some volunteer to emerge. We did have some moisture. I know we were thin on moisture, but we had some moisture that popped up there in that late summer that could have led to some of this volunteer emerging a little bit too close to planting for comfort. So a few things there that might have led to this year being a little worse than what we expect in other years. We also have, wheat that we have to worry about in cover crop or double crop systems, right? So that's a place we don't always think to look, and we do have more cover crop area in the state, so it's something we just need to keep an eye on when we're thinking about that green bridge.
Another virus to be thinking about right now, wheat soilborne mosaic virus, and can you tell us a little bit about that one?
Sure. There's a number of other viruses. So Kelsey did a great job of describing this complex of viruses that can cause what we generally refer to as wheat streak mosaic. But there's also two different viruses that can be surviving right in the fields, production fields, called wheat soilborne mosaic and wheat spindle streak mosaic virus. Both of those, as I mentioned a moment ago, persist right in the soil in the presence of a fungal-like vector or organism that infects the roots of the developing wheat plants, usually in the fall or winter, and usually in association with higher levels of soil moisture. So in the spring, there can be many things that can cause yellow wheat during this green up stage for some areas of the state yet. So it could be nitrogen deficiency, it could be winter injury. One of the possibilities would be these other wheat soilborne mosaic or spindle streak can also cause yellow wheat.
So not as easy to go out and identify in the field then?
It's not quite as easy. It can be easily confused with other things such as nutrient deficiencies or these other overwintering damage. And that's where, like Kelsey mentioned, the diagnostic support can be a big advantage for growers here in the state to take advantage of that resource that's available through K-State Research and Extension.
Mentioning one more virus, barley yellow dwarf.
Yeah, so barley yellow dwarf is another one we'll start to see here in the spring. And this one, luckily for us, it looks a little different than the others, right? So we just talked about these 3 streaky viruses that can be kind of hard to tell apart just by visualizing. But barley yellow dwarf has a more characteristic symptom. So usually we'll see either yellowing, or sometimes you see even this bright purple symptom at the tip of leaves. And you see this occur typically in patches in the field. So you see this typical like flame orange or purple tips on your leaves. And you'll also see stunting, right? Barley yellow dwarf virus. We see these dwarfed plants in patches in the field. So that's another one that sneaks up on us in the spring. It's vectored by aphids like the bird cherry oat aphid or green bugs. So we'll typically see that in kind of circular patches in fields where those bugs have colonized and landed, in really severe situations. It can be, large areas of field, right? So that's something we're also looking out for this time of year. And of course we can test for in the diagnostic lab.
I wanted to mention just a little bit more information about that diagnostic lab and how can people use the lab.
There's a couple ways. So you can send a sample directly to the lab. You can email them at clinic@ksu.edu, or you can go on the website for the plant pathology department and toggle right over to the diagnostic clinic and mail in a sample. Or you can work with your local extension, K-State Research and Extension county office. You can actually bring them a sample or work directly with your county or regional agent there to submit a sample, and they can submit that for you. So you can even bring it into that office. But that's a great resource. Anytime you just don't know, you've got some sick-looking wheat, you don't know what it is, the diagnostic lab can help with that, and other plants too, right? Household plants and garden plants, other crops. So yeah, it's a great resource.
That was K-State's Kelsey, Andersen, Onofre, and Erick DeWolf. We're cutting to a short break now on Agriculture Today, but when we come back, we'll once again be joined by Kelsey and Erick as we continue talking about wheat. You're tuned in to Agriculture Today, and we continue our Tuesday show talking with K-State Extension wheat pathologist and disease specialist Kelsey, Andersen, Onofre, and Erick DeWolf. Kelsey, Erick, as we continue our conversation, Erick, you starting it off with telling us about stripe rust, and before we talk about it, why is Texas important to this conversation?
Yeah, so the stripe rust and leaf rust, kind of its cousin here, right? Very similar fungi. They don't survive the winter very well in Kansas and states to our north. But they do survive in the warmer climates, warmer environments of Texas and parts of Mexico. So we often will focus on the environment and in those potential overwintering locations because it preconditions or primes the entire system, the cropping system within the Great Plains region, as to whether or how vulnerable it will be to the development of the disease. So ultimately, we're looking for moisture patterns, for temperatures that are conducive for the overwintering in these source regions like Texas. And those often provide some of our early warnings or first indicators that we could be headed for trouble with these different fungal diseases like stripe rust.
And what are we seeing for this year?
Probably the best way to answer that question is to put it in the context of a larger study that we've been doing for many years. So we can look at the last few decades of wheat production and when we've had major outbreaks of stripe rust here in Kansas. And then we can then look at these for weather patterns in these overwintering locations like Texas and see, is there any relationship between what's happening in Texas, say in November, December, or February in some of those fall and winter when the wheat crop is being established and beginning its spring growth in Texas. Is there any relationship between what's ultimately happening here in Kansas? And it turns out there is, that when we do see these abundant moisture or at least enough moisture to get the wheat crop established in Texas, and then enough moisture to continue to favor the disease development as we transition to these spring months in Texas, that often increases our risk for having major problems here in Kansas.
Does it look like we're going to have major problems?
Well, there's a lot of the growing season yet to occur yet, but many of the indicators, these early indicators that we mentioned a short time ago, are suggesting that the weather was indeed conducive for the development or the establishment of stripe rust in Texas and the continued development of the disease as we transition into our key growing season for wheat.
And are there conditions then in Kansas that also make it more susceptible to make its way up here and survive?
Absolutely. So it's not only just a matter of whether the population, the disease survives and then the population gets large in Texas, but we also need wind and storm systems to potentially move the fungus into our area. And then once it's moved into this area, it also has to have favorable environmental conditions to become established and cause infections in our wheat. So there's several pieces of this puzzle, so to speak, or the growing season that we just don't know yet. But there are a number of early indicators that this could be a high-risk situation.
When would producers start seeing potential impacts of it in their fields?
Well, I think that's a good question. So I think one of the things that we might consider maybe before we talk about locally here is that another piece of information beyond the environment is we might also talk about what are the observations of disease in some of these locations, like Texas or Oklahoma. And it turns out that not only has the environment been conducive, but sure enough, it looks like the fungus was there and is becoming established and potentially increasing now, setting itself up for these potential large populations that could move into our area. So we have not only a favorable environment, but boots on the ground are also saying, hey, there's disease here, maybe more than what we've seen in the last couple of years. So that's kind of the equivalent of kind of a lookout here is watch out. We need to be encouraging our growers to be doing a couple different things now. One would be to scout your wheat, right, as we transition to these from the tillering to the jointing and ultimately flag leaf emergence and heading stages of growth. We're going to want to ramp up our own scouting and monitoring activities for stripe rust and leaf rust and a whole host of other leaf diseases.
As they are out scouting and checking their crop, is it worthwhile for them going back and seeing what they planted and seeing if it is resistant?
Absolutely. So other pieces of information that will ultimately help them decide whether they need to take action or not would be to evaluate the genetic vulnerability of their wheat to stripe rust or to leaf rust or any of these diseases that might be causing problems. So this is a great time to go back to either K-State publications or other publications that they have access to that would help them evaluate which of their fields are planted to which varieties and what's the vulnerability of these different fields to the stripe rust.
And what can producers do if they do end up with stripe rust in their field?
Well, I think one of the things they might consider would be applying a fungicide. So unlike we talked about a short in the last segment about wheat streak mosaic, where there's very little we can do when we see the symptoms of disease, with stripe rust or other fungal diseases, there is something we could do. We'd actually consider applying a fungicide in that type of situation. So if we have a favorable environment, we know we're seeing the disease, and we know that there's a good yield potential of that crop, then we might consider applying a fungicide to help protect or maintain the yield and productivity of that crop.
Erick, you mentioned scouting fields, and so Kelsey, if people do see stripe rust in their field, do you want them to reach out to you?
Yeah, so these next few weeks are going to be critical here in Kansas. Like Erick mentioned, it's been detected in Texas now since January. We just had some reports of low to moderate levels or even higher levels in Oklahoma, in southwest Oklahoma. So we're guessing that within the next few weeks, if the weather remains favorable, we will see stripe rust here in Kansas, right? So now we're out scouting, and we will update our listservs and our we'll put these out in Agronomy eUpdates and also by radio when we do detect stripe rust. But if you find stripe rust, you can help us help you by sending us some of those reports, right? So we can't be everywhere in the state, so we really rely on a lot of our colleagues out in the state to let us know when they detect stripe rust so we can update the regional maps. So that's really important. I think also, once we have stripe rust established here in Kansas and moving, it's important to think through, if we're going to make that fungicide decision or not, right? So we'll be moving into our critical growth stages for that, which are typically when we hit that flag leaf phase, right? Our Feeks 8 and beyond wheat growth stages, right? So now's the time to start thinking through those fungicides. We just published our K-State Fungicide Efficacy Guide through K-State Research and Extension bookstore, right? So you can take a look through that and start to balance some of the options that you have that would be good candidates for stripe rust efficacy.
As we have talked about a lot of different things related to wheat today, Kelsey and Eric, as we round out today's conversation now, what are a few things that you'd really like to send home with growers?
I think the big ones, remember your variety, right? So just double check your Kansas Wheat Variety Guide for your variety resistance, right? Because that'll help you know if you have a variety that's resistant to stripe rust but maybe susceptible to leaf rust. That's going to help you, think through your fungicide application, or vice versa. If you're really susceptible to stripe rust, you might start thinking about a fungicide application. So it really comes down to, looking at the variety resistance that you have planted there, and scouting, right? So, we can't know what's going on every farm, right? So really getting out and scouting fields and checking and knowing that there are plenty of resources here to help along the way.
Now is the time to gather information. So this is information related to disease scouting. We can know some early indicators of what's happening in states to our south, but there's nothing that's going to replace just checking your own fields, gathering information, like Kelsey was saying, about your variety, your fungicide options that you have locally to you to make sure you're in a good position to make the wise decision if the need is there.
Eric, Kelsey, I appreciate you both taking the time to join us today and share with us some information about wheat as things continue to green up.
Thank you. Thanks for having us.
That was Kelsey Andersen Onofre and Erick DeWolf, who are both K-State Extension wheat pathologist and disease specialist. If you'd like to learn more about these topics that they talked about, one way to do that is going to the Agronomy eUpdates, specifically looking at the March 21st one. There is an article in there titled Outlook for Stripe Rust and 2024 Kansas Wheat Crop. Also in that e-update, you can find an article that links to the Foliar fungicide efficacy ratings for wheat disease management in 2024. I will, of course, link both of those in today's show notes on agtoday.net. And just a reminder that the Agronomy e-updates are a great way to stay up to date with what's happening in the agronomy department here at Kansas State University. You can find the e-updates and get signed up for them by going to eUpdate.agronomy.ksu.edu. And just a reminder about the diagnostic lab they mentioned in today's show, which I will also link in today's show notes. If you have any questions, you can send them an email at clinic@ksu.edu or give them a call at 785-532-6716. Again, that is 785-532-6716. I, of course, will link all of this in today's show notes on agtoday.net. We're cutting to a short break now on Agriculture Today, but we'll be back with more ahead.
This is Agriculture Today. Along with Shelby Varner, I'm Jeff Wickman. We end today's program with this week's milk lines. Ohlde Family Farms, a multi-generational farm that was started in the 1950s by Bob and Norma Ohlde with just 3 Holsteins, is being recognized as the 2024 Kansas Distinguished Dairy Family. K-State dairy specialist Mike Brouk says the dairy has grown significantly over the years. It now has 90 employees on 6 sites in 2 states and is milking 4,100 cows, raising 2,500 heifers, and farming more than 5,000 acres. This week, Mike spotlights Steve and Cindi Ohlde and their family, recipients of the 2024 Kansas Distinguished Dairy Family Award, just like Bob and Norma Ohlde and their family did in 1999.
Today I'd like to announce to our Kansas dairy farmers the 2024 Kansas Distinguished Dairy of the Year. This past Friday, we awarded that award to Steve and Cindi Ohlde of Lynn, Kansas. They're with Ohlde Family Farms, located in Lynn, Kansas, as well as a couple of other locations in Kansas and Nebraska. They were awarded this award for demonstrated excellence in on-farm production, management, and leadership essential to the well-being and progression of the Kansas dairy industry. We congratulate them and the farm on receiving the award. A little bit about their farm. Their farm actually was started back in 1953 by Steve's parents with 3 dairy cows. Those cows were part of an FFA project that Bob had at the time. He and Norma milked those cows by hand. Over the years, the farm has grown. Steve and Cindi actually officially joined the farm as owners in 1980, and the farm continued to grow as their family grew. In 2000, 2 sons, Kyler and Justin, became partners in the operation as well. By this time, the farm had grown to about 600 cows. As the family again continued to grow, in 2016, Levi, another son, was added as a partner to assist on the agronomy side of the farm, and they also added a heifer development yard that year as well. In 2018, they finished a cross-ventilated barn to expand their dairy herd at the Lynn operation. Then in 2019, they added another operation in Nebraska and also a composting operation up there as well. In 2023, the farm expanded again with the State Line Dairy as they installed robotic milking at that site. So today, over the 3 locations, they milk over 4,100 head of dairy cows, raise about 2,500 head of heifers, and farm over 5,000 acres. The Ohlde family has done a wonderful job in increasing production on their dairy herd and have a health program that emphasizes cow health and cow comfort. Somatic cell count on these dairies is about 190,000 cells per mill. So excellent quality milk produced by this farm. And they also use a lot of technology to keep track of the health of their animals. Some of this technology involves tracking not only their activity but also their rumination and eating behavior as they continue to monitor the animals very closely using technology to improve their efficiency of labor when it comes to herd health. Today, the farm continues to operate in a partnership. It's an excellent example of how we transition dairy farms from one generation to the next. The first transition was to Steve and Cindi from his parents, and now they have successfully transitioned the farm to 3 of their sons. A 4th son is not currently involved in the operation, but works in the area of farm finance in the region. This is Mike Brouk with K-State Research and Extension, offering congratulations to Steve and Cindi Ohlde and all of the employees of the Ohlde Family Farms for being the 2024 Kansas Distinguished Dairy.
Thanks, Mike. And that'll do it for this edition of Agriculture Today. For Shelby Varner, I'm Jeff Wickman. This is the K-State Radio Network.